Hi, you guys. Just want to get on here and say hi. I know this is terrible video, so I'll work on it, but wanted to say hi since we're not going to get to see each other for a while. And this is going to be my first review, so we'll go ahead and get to that review. So we are going to review these topics today within this video, and that is why is it a quadratic? Okay, what makes something quadratic? Um, Stuff about the graph, about the parabola opens up or down, wide or narrow, vertex, y-intercept, x-intercepts, axis of symmetry, interpreting the points on the graph, and then the three forms of quadratics and what they tell you. All of this review should help you with your Khan Academies for today. So we'll go ahead and get started with that. And the first question is just simply, why is it a quadratic function? What makes it quadratic? How can we go from there? So very simply, if you look at a graph, if you see something that looks like a parabola, like a U-shaped either up or down, then you have a quadratic in that case. But the other thing is based on numbers, what makes it quadratic. So we know that we have three different types that we're looking at right here. The pattern, if it's linear, is going to go something like 2, 4, 6, 8, 10, and it's going to grow by the exact same number. So this is plus 2 every single time. So it's growing by that same quantity every single time. We then had the exponential, which is a little bit different, and that's where it went 2, 4, 8, 16, and so on and so forth. And this was because it grew by a multiplication of 2 each time. So you multiplied each number by 2, and it went from there. And then we got into this new idea of quadratic. And when we saw a quadratic one, we weren't really sure that it was quadratic at first. We had to figure out what was going on. So one of the examples that I gave, which was a large numbers, but it made us kind of think through what's happening here, is I gave this and I said, okay, let's think about what would come next and what kind of function this is. So the reason this one is quadratic is because from 99 to 89 is going to be, hold on for a second here, we're losing some, there you go, is going to be a minus 10. From 89 to 76 is going to be minus 13. So what I'm getting from 99 minus 10 is 89. 89 minus 13 is 76. Go from 76 to 60, it's a minus 16, which gets a pattern going. Well, what this tells us, since those minuses are not the same, is this tells us that it's not linear. But we don't know about quadratic yet. So if we look at the second level of differences, to go from negative 10 to negative 13, you go minus 3. To go from negative 13 to negative 16, you subtract 3. So since these are the same, that's what makes this one a quadratic, is what we talked about. Because it's the second level of differences that is the same. So that's why is it quadratic. If we go on to, is the graph, does it open up or down? Okay, up or down is just simply based on positive or negative a values, but this one opens up. If we're going to answer that, is it wide or narrow? So this is where we talked about from the vertex, does the next point over, so 1 unit to the right, go up by 1? Because that's what a normal y equals x squared is the general function. That's what the normal function would do. So this one does. So this a value in this case is 1, and that means it's not narrow, it's not wide. Okay. If the a value to get a wide function, if the a value versus a narrow function, narrow is going to have an a value that's greater than 1, and this one's going to have one that's between 0 and 1. And that's the absolute value of the a value that's going to be doing that, because we're not looking at the positive or negative. You use the positive or negative to look up or down. The vertex tells us the shifting of the graph. So this vertex here is at 1, negative 4. That tells us the graph shifted 1 to the right and 4 down. That also, in this case, is a minimum. Sometimes it's a maximum. So this is a minimum. You're going to see different words like this come out. And it tells us our shift. So this graph shifted because every vertex starts at 0, 0. So it shifted 1 to the right and 4 down to change where this graph was. Again, it did not make it narrow or wide. It didn't flip it over, anything like that. It just had the shift. Y-intercept. So the y-intercept in this one is right here, is at 0, negative 3. For a y-intercept, it's just where it intercepts the y-axis. The x-intercepts in this one are at 3, 0 and at negative 1, 0. That's just where it intercepts the x-axis. So these are x-intercepts in that case. The axis of symmetry is right through the vertex. It's going to be a vertical line right through the vertex. And in this case, what we really care about is the x value of this axis. This x value is 1. Okay, so that's our axis of symmetry. So that's all of the different pieces of the graph. If we keep moving on from there, interpreting the points on the graph, I just gave 2 examples. My suggestion in this in Khan Academy is just kind of go through them. You'll kind of figure it out as it goes. But some really good points here. Pay attention to the labels on the x and the y axis. So pay attention to the fact in this one, this is time in seconds. So this is talking about how many seconds something is. And this is height in feet. So this is talking about how many feet it's covering. Okay. Make sure you read the question carefully. Think about what it's asking. Okay, so this one asks how much time elapses while the rocket is 600 feet above the ground. So this is giving a rocket's trajectory. Again, you don't have all the information, but a rocket, how far it is above the ground after how many seconds, what it's doing. Remember, the rocket is actually going to take off and go straight up, and then it's going to come straight back down. So this distance here is not based on the distance it's covering. It's not actually doing this. It's just the time that it takes to do each one of those things. Okay, so how much time elapses when the rocket is 600 feet above the ground? Well, it's 600 feet from here all the way along this time, all the way to here. And so that time that's elapsed is between 1 and 5 is 4 seconds. Okay, if we look at this kind of an equation here in the top right, I've got a selling price versus a profit. And what this one's looking at is if I sell my item for $20, so let's say that I'm selling it at $20, I believe my profit's going to be at approximately $4,000. If I sell my item at $50, then my profit's going to be the same, which seems kind of strange to some people. You have to think about the less priced of an item, the more people are going to buy it. The higher price, the fewer people that are going to buy it, but you still make more of a profit if it's higher price than if it's lower price. So you've got kind of different things going here. But that's selling price, which is why they want to find a middle version of it. And so what this maximum right here represents is at what price, so probably somewhere around $35 here, are you going to get the maximum profit? That's an example. Or at what price will you make no profits? That'd be about $10 here, or about $60 here that you would make no profit that you might be looking at there. So again, lots of different things, but just think about your interpretations. Lastly, we want to talk briefly about the 3 forms of a quadratic and what they tell you. Okay, so remember we have this one here is standard form. If you have no parentheses in it, you've got standard form. Everything's multiplied out. You have your x squared term first, your x term second, and your constant third. Okay, this here is vertex form. You've got a parentheses squared, that's going to be vertex form, and this here is intercept form or factored form. We called it both. And that's going to have the 2 parentheses. Sometimes there's a number out front as you go through there. Standard form, what standard form is going to tell you is it's going to tell you the y-intercept, and that is always the last number, the constant that's by itself. Our y-intercept here is 6. Vertex form, just like the name tells you, is going to tell you the vertex. In this case, this vertex is 3, 7. It's the opposite of what you see in here, and it's the same as the 7 that's on the outside. So that's where those are coming from. Intercept or factored form is actually telling you your x-intercepts, and your x-intercepts are going to be the opposite of what you see in here. So it's what makes this whole thing equal to 0. So that would be an x value of 3, and this one would be an x value of -5. So the x-intercepts are 3 and -5 in that case. Again, that's a little bit more complicated, can get more complicated than that, but essentially what you do is you take each parenthesis, you set it equal to 0, you solve, and you get x equal to 3, which more simply is the opposite of what's in here. But remember, when a number comes out here, it gets a little bit more difficult than that. Okay, so we'll conclude right there for today. Do your Khan Academies, and we'll pick up again tomorrow.